Afternoon, everyone. So in this poster presentation, I'm going to talk about QCD resumation in the lattice calculations of parton distribution functions. So this talk is about the QCD resumation, especially the threshold resumations in the lattice QCD calculations of PDFs, including the large momentum effective theory or the quasi PDF and the pseudo PDF approaches. So um, uh, the motivation is that many present lattice QCD approaches calculating the PDFs rely on a factorization formula or effective theory expansion. And there is a threshold region when the parton momentum of fraction x approaches 1 where there would involve large logarithms that need to be resummed in the matching coefficients. And this could affect the determination of the large X of the PDF. For example, there has been long debate on the large X exponent of the pion valence PDF. So near X equals 1, it has a power law behavior of 1 minus X to the beta. And there has been discrepancies on whether beta is close to 1 or close to 2. So we find out that in the one loop factorization formula for both the quasi PDF and the pseudo PDF approaches, there involves threshold logarithms structures. And uh, here is an explanation of where they come from. So both the quasi PDF and the pseudo PDF can be related to a three-dimensional TMD-like distribution, but it is defined from a straight gauge link. So this 3D distribution under different limits reduces to the quasi PDF and the pseudo PDF. We find that the threshold logarithms originate from the leading self-divergence in this 3D distribution. At one loop level, the contribution comes from these vertex-like diagrams. So if we evaluate these diagrams and in the limit of x goes to 1, we find in dimensional regularizations that the leading self-divergence of the quasi and the pseudo distribution goes like these two equations. So as you can see, if we expand the results around epsilon equals 0, we get logarithms of 1 minus x divided by 1 minus x. But because of the different signs of these exponents, the signs of the leading threshold logarithms would have opposite signs in the quasi and pseudo distributions. And they actually will correspond to an infrared a Landau pole or a UV fixed point if we resum these logarithms. You can find an explanation of why they have such different behaviors in the quasi and the pseudo cases. So with these threshold logarithms being abundant, we can perform a standard resumation of these logarithms. So our approach is to study the operator product expansion of this matrix element in position space. And we find that for the Wilson coefficients that depends on the nth order of the Maillard moments, it does indeed include leading double logarithms and subleading single logarithms that corresponds to the threshold limit. And by performing the standard resummation, we obtain the resummed Wilson coefficients. And if we include the DGLAB evolution of the Maillard moments, we can plug this resummed Wilson coefficient back into the OPE formula. So based on this OPE formula, we performed an analysis of the pion valence PDF based on lattice data from a previous calculation done by some of the authors. So we compared the threshold resummed Wilson coefficients with the previous analysis that only has one loop fixed order Wilson coefficients. So in this figure 2, we show the results. The blue and the red bands are uh, the, the fourth and the second moment of the pion valence PDF. And we have calculations at the two fine lattices with spacing 0.04 and 0.06 Fermi. and which allows us to do a continuum extrapolation. And we also compare our results with the previous one, which is the NLO, one loop order, fixed order OP analysis, which is the red line, and the blue line, the solid lines, and also compare to experimental fits from the JAM and XFitter and the ASV groups. So we can see that our result doesn't change our previous analysis very much. The main reason is that the large logarithms appear at large orders of many moments n. So for the second and fourth moments, the n is too small for threshold resumation to be important. So this makes us believe that in the future, if we want to study the large X behavior, we need to be able to access higher moments by both including larger boost momentum for the pion state, as well as increasing the statistics. Uh, and so that the threshold resumation will also become a important systematic correction. So that's the main message of this talk. Thank you.